Hey guys, I recently gave a presentation on Node.js web security with a little bit of AWS security built in as well. And so I decided to replicate this presentation and post it up here on YouTube just for future reference or for anybody that's working on Node.js or cloud-hosted projects on AWS. Um, so basically this presentation is best practices that will keep you secure. Node.js, if you're not aware of it already, is basically JavaScript for the backend. It's basically an entire server implementation written in JavaScript. You can code JavaScript on the backend and the front end, and that can be your entire application. So because of this, there's some special security considerations that you have to take into account. Now with this presentation, I'm not going to be focusing on your typical security concerns like, oh, you should use SSL, or oh, you should hash your passwords, or you should use this particular password hashing method. Those are all kind of general security considerations. Instead, I'm going to be focusing on some perhaps overlooked security concerns, things like STS, CSRF, CSP, X-frame options, cross-site scripting, a bunch of other acronyms that hopefully by the end of this presentation you'll understand what all of them mean and how to protect against them. And furthermore, I'm going to be talking about how to approach those things from the realm of Node.js. So to get started, Node.js basically follows the same security requirements for any other backend technology. Node.js is obviously the focus of this presentation, but it doesn't mean that you can bypass things like properly storing your database passwords or sanitizing user input, those kinds of things. There's a lot of node-specific security considerations, as I mentioned, and I'll be going through those a little bit. But the first thing I want to do is talk about how a potential attacker could profile an application that you have running up online somewhere. So basically, one of the first questions I was asking in this presentation is how an attacker can instantly determine the technology that a web app is using. And so as a hint for this, you can look in the headers that's returned by the application. So basically, the answer to this is the X powered by header. If you're running Express, you get a header that says X powered by Express. Now, there's a concept known as security by obscurity, and there's security through obscurity. And what this basically means is that are you more or less secure if an attacker has to guess the technology stack or the environment that you're running in, rather than just telling them. And I argue that you're slightly more secure, but it is not an only preventative measure. So, you can use security through obscurity. You can hide your headers all day long. It won't stop a potential security concern if an attacker is persistent enough. But that doesn't mean that you shouldn't do it. So basically, you have this header. You can disable it. What does it mean? It means an attacker potentially has to spend a lot more time trying to profile your app to figure out what technology it's running, and this could lead to him getting caught by a web application firewall or caught by an intrusion detection system or some other mechanism that would potentially slow down his attack. So basically, the advice here is disable this header. There's no reason to keep it. Maybe you're using it in testing purposes. I've never really seen a production reason to keep it. The next thing I'm going to talk about is something called parameter pollution. So basically, parameter pollution works in the way that's demonstrated by these following examples. So first I'll ask, what does the following code do? You have a server up, it's got an API endpoint, you can pass in the parameter Bob. And then the response in Node.js says res.send, hello, and then it adds in the query name. The answer to this is it sends back to the user hello Bob. But what happens in Node.js if you add multiple parameters? So basically, and they have the same name. So you have API parameter name equals Bob and name equals Sally. Now some frameworks, PHP, they handle this slightly differently, but you need to watch out for something called parameter pollution. And essentially in Node.js what happens is you now have an array. Whereas previously the name Bob was a string, you now have an array containing both Bob and Sally. So what does parameter pollution mean? Well, in some frameworks keep only the first element or only the last element, and they return it always as a string. But Node and Express will combine multiple parameters into the same name into an array instead of using just the first parameter. So what does this mean? This means that an attacker could essentially inject content into the application that isn't expected. So if you're expecting a string and you're working on a string, maybe you're doing things like you're expecting a string and you're trying to do an operation or call a method on a string, and you actually wind up with an array. This can cause either the app to crash, that's probably the least of your concerns, or it can cause maybe an array to be inserted into a database lookup, return multiple rows. There's really a limitless breadth of opportunities if you're able to pass something in that's not expected by the application. So essentially the best thing to do here is to check for the parameter type by doing type of name as the parameter. Make sure it equals string. If it doesn't equal string, then send back an error. The next thing I want to talk about is something called strict transport security. Basically, strict transport security is an option that should be used in combination with SSL. So if you're using HTTPS on your web page, as you should be if you're collecting any kind of personal information, or it's kind of becoming a recommended best practice to just use SSL all the time. But anyway, if you are using SSL, strict transport security is an optional header that you can set, and basically what it is it tells the browser, don't serve this page unless it's being served over SSL, and this prevents attacks known as SSL stripping, where essentially a man-in-the-middle machine is able to strip SSL out of the app, send you the resulting page, you enter in your information, they collect it and pass it on to the server. So what this does is basically prevents you from being served a page unless it's served over the original SSL. In Node and Express, it's very easy to set this. You just do res set header, strict transport security. You can set the age and whether or not you want to include subdomains. The next topic I'm going to head on over to is cross-site request forgery. So you've probably heard of CSRF in the context of attackers being able to submit forms or information to an application on behalf of a user. But if your application uses post data at all, then it should definitely use CSRF tokens. And basically what this means is that when you load the web page, the server sends over a token. That token has to be included in any subsequent responses that are sent back to the server, or else it will fail. They're really helpful on login pages, any kind of form submission pages. If you don't use a CSRF token, what an attacker can do is submit a form hundreds of times. They can embed a form inside of a web page, and a user can submit it, or it can be submitted on behalf of a user without them ever knowing it. And it can be all happening in the background. So that's really not a good thing if you want, say there's a password reset form. If I'm able to reset your password from a remote domain that's not the original site, that's not a good situation. So use CSRF tokens. It's very easy in Express, app.use, express.csrf, and when you're rendered, if you're using EJS templates, you can do something like res.locals CSRF token, and you can stick that in a hidden input form. You can stick it back in the headers. There's a number of different options. One thing to note is with the latest Express version, they've been removing some of the middleware, so you actually have to install a module now using npm. Do npm install csurf is the module, CSURF. If you search for that on the npm website, you should be able to find that with pretty simple instructions on how to set it up. But it works the exact same way that the Express CSRF middleware used to work. Cross-site scripting, everybody knows what that is, but in the terms of Node and Express, it's just important to remember that when people are injecting JavaScript in your page, it could be actually injecting code into the back-end operations of the page. So I'm not going to go too in-depth with the cross-site scripting, but you basically just need to make sure that you're sanitizing all your user input. Never, ever, ever trust user input. When they're entering stuff, you need to convert all the special characters into their HTML representation. So for example, here I have the greater than, less than signs, ampersands, quotes. Pretty much anything that could be used to escape out of code needs to be converted to an HTML representation. There's a new feature out nowadays called content security policy. Content security policy is a really great way of instructing a browser not to take specific actions. So for example, you can tell the browser that you can only want to use content from a specific domain, reject any scripts that are hosted on a different domain, and this would prevent people from injecting malicious JavaScript into your page. You can prevent inline JavaScript, so only allow JavaScript that's in external files. There's really a lot of different options, but in Express, sorry, I went back there. In Express, it's really easy to set the header. You can do just res.header, X content security policy, and then specify the policy. There's a lot of good documentation for this on the Mozilla Developer Network. You can check that out. There's also OWASP, owasp.org, I believe the website is. It really goes through a lot of different CSP header examples. So let's talk about cookies for a little bit. Essentially, whenever you're setting cookies in your web page, there's some different flags that you should be using. The first is the HTTP only flag. This basically tells the browser only access the cookie via HTTP and not from the page itself. So if somebody, for some reason, was able to inject JavaScript in your page, was able to get a cross-site scripting demonstration working, they would not be able to access the user's session cookies or any other cookies for that matter that have this HTTP only flag. The next flag is the secure flag, and again this is another option that should be used in tandem with SSL, but it tells the browser not to serve cookies unless SSL is used. So if somebody was able to strip SSL out, the cookies would not be served. In Express and in Node, this is really simple to set up. When you do the app.use express session, you can specify under your cookie option here, you can specify the HTTP only and secure options as true. The next topic is X-frame options. X-frame options are a really good way of preventing an attacker from embedding your website inside of theirs. So there's a concept known as clickjacking, and clickjacking is when an attacker embeds your website usually within an iframe, and then they put content over top of the website to collect user input. So for example, I would take your website, I'd host it inside of my website inside an iframe, then I would stick an overlay div over top of it, put some hidden input fields over top of the password and username fields. That way when a user's clicking in there, they type in their username and password, they hit enter, they're redirected the exact same way, they never know anything happened, but in the background those hidden elements were collecting the username and password information from the user. So what X-frame options does is it tells the browser, don't allow this page to be served unless it's being served from the same domain, if you have like a same origin option set, or you can just set deny, which will prevent the page from being iframed at all. So if you've ever heard of frame busting, this is basically that. It's forcing the browser to view the site in its natural state, not embedded anywhere else. So in Node and Express, the easy way to do this is res.setHeader X-frame options. You can use deny, like I said, that'll prevent any iframing, or you can do same origin, which will only allow you to iframe your own site. So user enumeration, this is really not a node-specific concern, but it is a security concern in general. And it basically is kind of a mix between security and a mix between the way that error messages are written. And user enumeration is when a user is an attacker is able to iterate over tons of different username combinations. They're not locked out at all, and they use the content of the error message to determine whether a user exists or not. So if you have a very standard error message, something along the lines of like username or password is invalid, that doesn't give an attacker any information in terms of whether or not the username that they tried is valid or not, and maybe just the password was wrong. However, if you give an error message that says something along the lines of that password is not correct for the given username, that implies that the username was correct, but the password wasn't. So you can see how the slight differences in the way that the error message is worded can really give a lot of information to an attacker. All right, so this concern here deals with node modules, and it's very specific to Node.js, obviously. But in Node.js, there's this concept of using modules within your application. It's very easy to require additional modules that offload a lot of functionality into these modules, and they're really a very helpful and a really great concept of the programming language. However, from a security standpoint, they also introduce a lot of vulnerabilities. Anytime you include a module in your own project, you open yourself up to every security vulnerability that may or may not be present in that particular module. So if you, for example, the passport module is included in a lot of projects because it allows for users to log in. They can include a login form, a Google sign up, any kind of thing like that. But if the passport module were to have any kind of security concern, then that's immediately reflected across every application that uses it. So I'm not saying that you need to audit every single line of code from every single module that you use, but you should definitely stay ahead of the curve by reading up on security advisories for Node.js modules. I have a number of resources in the resources page for this presentation, but you should definitely understand what a module does, and if a module has functionality that you're not using, don't include it. It's a pretty simple concept, but I've seen countless applications where people include tons of Node modules, they have no idea what they do, and they wind up introducing concerns into their application. So this last thing I want to talk about is AWS security in general. IAM roles is the first concept that we want to cover. You should never, ever, ever be hard coding AWS security credentials into your application, ever. If you need access credentials, there's a concept known on AWS as IAM roles, and basically what that does is it gives the particular resource, maybe it's an EC2 instance, it gives it temporary access to other resources on AWS. So if you need resource access to a specific bucket, you can tell one particular EC2 instance that it has access to a bucket for a limited period of time. When the instance boots, anytime you use the AWS command line tools or the Node AWS SDK, it is able to download the temporary credentials, use them to access the resource, and then it's done. If somebody were to hack into the machine, you can reset these credentials, you can expire them. They're much easier to contain a potential security intrusion than if you hard code security credentials into your application. It's a terrible practice to hard code for security credentials, and you should never, ever, 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 ever do it, except for maybe testing. The second thing is security groups. This is something you should be using on AWS, and you should be going by a most restrictive first policy where you limit the application or the resource, maybe it's a EC2 instance, you limit the amount of access to that resource, and then you then allow what's needed. So by default, everything should be blocked, and then you should assign particular groups very limited access rights. So what we've been doing, we've been using AWS security groups for individual access rights. So we have a group called public HTTP, and what that does is it opens up port 80 only to the EC2 instances that we connect to that security group, and that's the only thing that that group does. We have another group for SSH. It only allows SSH from a particular IP address. We have another group for HTTPS. We have another group for maybe monitoring ports. And basically this prevents us from adding too many rules to a specific group. And then for the EC2 instances that we boot, we connect only the security groups that are needed, and that allows us to maintain the optimal level of security. And one other thing to note is that security groups do not replace service level security. So what I mean by this is if you have a particular application that needs an instance that needs SSH access, just because you're restricting SSH to your IP addresses doesn't mean you should be sacrificing on other options for SSH. You should still disable root login, you should still only allow login by keys, that kind of thing. So a security group is not a foolproof method, but it's definitely preferred over just leaving everything wide open. There's another topic here, VPCs, virtual private clouds. These are super easy to set up on AWS. But if it's an internal resource and it only needs access to maybe some other machines, or it doesn't need access to the internet, or it shouldn't have inbound access from the internet, don't make it public. It doesn't make sense for it to be out there. You can create tons of subnets and specifically routed groups in VPC. It's super easy to set up. Let's see here. This AWS IAM users and groups, you can specify very granular level permissions in IAM. You should never have a star.star permission level. What this means is it is giving any action allowed to any resource. So you should fine-tune this as specific as possible, even down to the S3 bucket level if you need to. One other thing here is just a common mistake that I've seen. It's not necessarily a mistake, but it's I guess a best practice. If you have a machine and it's behind a load balancer, it should not have port 80 or 443 open to the public. The only thing that needs to access that resource is the load balancer. So you should only allow inbound traffic to those ports from the load balancer, not from public. This prevents people from deep linking directly to your IP address, and it also encourages people to use the load balancer, which is what it should be used for, rather than linking directly to your EC2 instance. So this is just a final note here that I have on prevention versus reaction. It's much easier to make security something that's built in ahead of time than it is to try to scramble at the last minute. There's been countless times where I've been wishing that I had done something sooner, or wishing that I had maybe applied a different security group or made them easier to use, rather than just opening everything to the internet and trying to deal with security concerns later. So here's some resources that help you out. There's an OWASP resource in here I mentioned earlier, some EC2 best practices, some node-specific stuff as well. So thanks for watching this presentation. Hopefully you got a lot out of it. If you have any questions about this, leave a comment, and I'll definitely do my best to get back to you. Thanks for watching.